name is Sylvia Okafor, and this is my partner Kayla. And we did our statistics project on Gatorade versus water and how it affects an athlete's performance.
Okay, our question is, does Gatorade improve a sprinter's 100-meter time? We will use an experiment to test our hypothesis.
Before we began the experiment, we did some research on other experiments, and we found that many other experiments used a statistical test. Many other experiments used a similar test on Gatorade versus water while participating in some form of exercise, such as University of Wisconsin. They found that people who drink Gatorade and walk on a treadmill for 90 minutes in hot conditions have lower rates of perceived exertion than others who drink water.
Our materials were 2 bottles of red Gatorade, 2 stopwatches, cups, and 1 measuring cup.
How we collected the data. We numbered the boys and girls who sprint on Potomac Seniors High School track team. And from 01 to 50, then we used the calculator to randomly select 5 subjects. We had one non-response because he was injured, so he couldn't run. And then we tested each sprinter individually. We poured a half cup of Gatorade for them to drink. Then we waited 2 minutes for the drink to settle. And we had one person stand at the start with a stopwatch and another at the finish with a stopwatch. And we averaged it 2 times together to get these results. And after we finished conducting the tests, we averaged the Gatorade time and subtracted it from the average water time for each subject. After that, we got the average of their differences, which amount to a mean difference of 0.035 and a standard deviation difference of 0.151.
Our inference test was state we plan to test HO. There was no difference in the mean 100-meter dash time after drinking Gatorade and the mean 100-meter dash time after drinking water. HA was there's a difference in the mean 100-meter dash time after drinking Gatorade and the mean 100-meter dash time after drinking water. Where mu1 is mu1 is the mean time after drinking Gatorade and mu2 is the mean time after drinking water. We will use a significance level of 0.05. Plan, we will use a paired t-test for the mean. Random, the simple was selected randomly. Normal, the graph is approximately normal. There are no outliers. The graph is on the next slide.
So subject 1 had a mean difference of negative 0.05. And subject 2 was kind of the outlier in this project. They had mean difference of 0.25. Subject 3 had no difference, and subject 4 had a mean difference of negative 0.07.
Okay, independent, 4 times 10 equals 40. There is reason to believe that there are more than 40 people on the track team. Do conclude, since the p-value 0.3615 is greater than the significance level of 0.05, we fail to reject the null hypothesis. There is no difference between the mean 100-meter dash time after drinking Gatorade and the mean 100-meter dash time after drinking water.
move on. There are lurking variables and errors within this experiment, and I believe that our results are not accurate because there are too many lurking variables in our experiment that would ultimately alter our conclusion. We had one non-response, and a couple of lurking variables would be the weather, how hot or cold it is, because it depends. A sprinter what the subject ate prior to running, if they had a heavy meal or if it was like a light meal, which could affect how much energy they had. Sprinters' health, if they were injured or not. The wind, because wind is an important factor in track. And the sprinter's motivation to actually try in the experiment. There weren't enough trials. We only did 3 trials because there wasn't enough time to do multiple trials. And how much sleep the subject had prior to running, because they could have been tired. And the subject could be having a bad day. And yeah.